Hi, everybody. Good evening. I'm Erin Hussein, and I'm the Associate Director of Alumni Relations for GSAS. And as GSAS alumni, you are part of an alumni group of over 46,000 GSAS alums around the world. I'm so glad to be connecting with all of you in this virtual format this evening. Welcome to episode 9 of GSAS Conversations in virtual form. Through GS Conversations, we have traveled with GSAS alumni to Wall Street, medieval Europe, the press room of the White House, urban centers, the new JFK Terminal 1, the vineyards of Italy, the World Series of Poker, and most recently to schools impacted by COVID in India and the Middle East. Today, I welcome Kobi Abayomi. Dr. Abayomi earned the PhD in statistics in 2008, and he very recently joined the Warner Music Group, where he is Senior Vice President for Data Science and Analytics. You'll be muted throughout the presentation, but you can ask questions during the chat function. We also have a number of questions that came in during the registration process, and we will ask as many questions as we are able to. With that, I introduce Dr. Abayomi. Thank you.
Thanks, Erin. I'm glad to virtually be back on Columbia's campus and in service of the alma mater. Looking forward to having a nice conversation. We'll have, I have my slides and presentation to go through, and go through that. But I'm looking forward to answering questions and speaking more with more verbosity in the Q&A section. So looking forward to get started. So we can start off with the presentation if you're ready.
There we go. Okay.
Great, thank you. So that's me, Kobi Abayomi. I just started at Warner Music. Before that, I was at Warner Media. I've spent about 6 or 7 years of my career doing applied work on the corporate side, and before that, I was a professor of statistics at Georgia Tech and Binghamton University. I want to talk a little bit about sort of the measurement behind inequality, give a couple sort of observational examples, and then at the end of it, we can sort of have a free form sort of discussion, and it'll be interesting to see where the conversation goes. Okay, so next slide. So first, starting off with just basically some sort of fundamental sort of notions behind inequality. As a statistician, we approach things from our ability to measure them. I still teach statistics to undergrads and graduate students. And I'm always reinforcing that statistics is the science of experimentation. There's an underlying experiment, right? And from this underlying experiment, we get data. What's the underlying experiment or notion behind a concept as broad as sort of inequality, which, is in the popular zeitgeist. I remember being in New York in the early 2000s in the Occupy Wall Street movement, and people taking over Zuccotti Park in the aughts, and so this notion is circulated through the public discourse, and I just want to start off with some of the antecedents of it and some definitional perspective on what inequality is. So if you'll just go forward again and then again, just one more time. Yep. Okay. So I love this quote from Bertrand Russell, one of my favorite mathematicians / philosophers, and you'll find a lot of many of the people in the talk are sort of contemporaneous, late 1800s to middle 20th century, knew each other, wrote to each other, spoke of each other. It was a very fertile time for statistics, which is relatively late to the mathematical sciences, and for people concerned about social policy and measurement. So I love this quote from Russell. If there were in the world today any large number of people who desire their own happiness more than they have desired the unhappiness of others, we could have paradise in a few years. So this is an aspirational expectation for humanity, right? But underneath it, there's this notion that sort of we're all in it together, And one of the sort of difficulties is the perspective we take on that sort of togetherness. And so that's one of the themes that I like to come back to when we start talking about inequality. Can we go to the next slide, or just hit the arrow? And one more time. So as we're discussing it, there are some things that are sort of axiomatic that just are sort of offered as principles or ways that it so the points of departure, if you will. And then next arrow, dependence. This notion of dependence, that the underlying sort of population in which we sort of talk about or measure inequality has an interdependence. The notion of scarcity that sort of runs as a current through any sort of economic conversation. One more time. The notion of measurement, how we measure something and versus how it may be obfuscated. And then once more, I offer at the end of this talk some illustration of a measurement of equality from an observational perspective. There's always a difference between noticing some things are coincident and being able to say one thing predicts another. But that's part of the art of being able to understand and measure things. All right. And then please to the next slide. All right. So a good place to depart and begin talking about the measurement of inequality is with Rawls' theory of justice, sort of a more modern take on welfare economics. And welfare economics is sort of the study populations in general and ways to sort of apportion resources. And when we talk about inequality, we're down to sort of a microeconomic sort of conversation, right? We talk about income equality most of the time, wealth inequality. Those are the popular sort of things to discuss. But the notion of the entire society's welfare and its association with the distribution of goods and resources are very closely linked with our ability to sort of measure it individually and speak about inequality for a population and how each of us feel it. If you go to the next slide. So this principle of justice, I think, is a great way to start off talking about inequality. Well, as an axiom, what's the best way to organize a society or to apportion goods, consumption, income, wealth in a fair way? And then Rawls has a nuanced argument. Fairness can't just be instantaneous, right? Like I can't just say at this point, history has begun and everybody has the same income. When we're talking about inequality, we know, and this is in the zeitgeist and reported on in the New York Times or whatever you can pick up these days, that there's a difference between wealth and income inequality, right? And equality in one does not subsume or create equality in the other. And so Rawls had this notion of being able to supersede accidents of natural endowment, themes we hear now in more contemporary discourse on inequality and its measurement. One more slide. Once more. All right, so what does that mean? This notion of liberty, which is a good thing, but this notion of the distribution of wealth, right? Well, it need not be equal. It must be to everyone's advantage. And so when we look at these observed inequality statistics a little bit later in the talk, so behind the notion of inequality, and I'm sort of presaging where we're going to end up, is this notion of uniformity, right? And if we're talking about a population and the way in which they experience, enjoy, get to partake in some good, the most sort of banal version of inequality is everybody gets the same thing, right? Is that the best thing for society? Is that utilitarian? Is that useful? And Rawls answers that question by saying it need not be equal, but it must be sort of to everyone's advantage. And this is something we should think about when we start looking at the observations of inequality at a macroeconomic level. All right, please, next slide. Once more. All right, so Rawls is a guide for constructing society and a suggestion on how we should measure or evaluate it. And so we'll just go forward one more slide. So the brief sort of aside into welfare economics, this is not a talk about welfare economics. The link between welfare economics and inequality is that each of these are measures or ways of describing distributional behavior. And in fact, inequality is is only meaningful when we're talking about measuring quantities across distributions or populations. So we have the Malthusian perspective. Some of you may be familiar with that. I remember being back in high school debate many years ago, and if we weren't prepared for an argument, so this type of debate I did, you had positive, you have negative, you affirmed a resolution, or you engaged it. One of the standard arguments we had to negate any positive or affirmative argument was that it would make more people and the world would be destroyed. The sort of Malthusian argument, right? A sort of desultory way of looking at the world. Go forward one more time. We have Ramsey, again, Ramsey, a contemporary of Russell and some of the other people we'll see later on in this talk, with this notion of wealth being problematic, ethically indefensible, a polite expression for rapacity, a mathematical theory of saving. So another one of these welfare economic guys, sort of the opposite, if you will, of the Malthusian take. But the notion of distribution or distributional measurement is beneath his work. One more slide. And then we have Hotelling, another mathematician, statistician, economist, and the quote I take from him: "Problems of exhaustible assets are peculiarly liable to become entangled with the infinite." And so now we've entered in beyond this synchronous notion of inequality. Now we're talking about measuring a sort of distributional quality or metric across time, right? This notion of there being a time period and the time period here being infinite. And so all of these things have to do with how we measure and assess a distributional quantity, and they're good sort of precursors for when we do start to look at how we do measure it and the trail that we end up on. All right, please, once more. So this is just, I throw in a couple slides here just to scare you, some mathematical equations. These are just translating sort of the maxims that are written down, right, in narrative form by Malthus, Ramsey, and Rawls into equations on welfare functions. We can skip these, but we can come back to them later if you'd like to talk about it. But what I'm trying to get at here is that, and this is like a cartoon sort of picture, right? For each of these different notions of welfare functions, for each of these different ways of maximizing how society uses its resources, underlying it is consumption. And so what we're talking about is an apportionment of consumption. That's a very important distinction to make. And this is something I hope we come back to later on in the discussion. When we talk about inequality and measuring of these days, again, we do it in a sort of distributional way, talking about within a population. We can segment populations, but we talk about it within populations. Underneath this notion of equality of wealth, equality of income, is a sort of constant notion, or sort of an immutable notion of consumption, right? And so that's something else that I think that we should deal with in a mature discussion on inequality. Let's go forward one more time. All right, so measuring inequality. What does that look like? Let's go forward once more. So this is a little bit of statistics. Take you back to your undergraduate days. This is an illustration of an empirical, i.e. Just calculated straight from data, distribution of income. This is the Consumer Price Index. I forget what the other part of the acronym stands for. But this is income statistics, and it's rather old. It's actually, this is a slide I've been using for a long time, back when I was doing theoretical research on this sort of stuff. But what we see here on the left-hand side, you can't see my arrow, but on the lower left-hand side to the upper right-hand side is the space on which this curve, the cumulative distribution function, lives. And this function is a function from a value. In this case, the value is the household's income to the share or probability that any household has that value of income or less, right? Hit the arrow just one time, and I think this animation will start which should be illustrative. Maybe not that one. Can you go back and just hit the arrow? There should be an animation. Yeah. Hit the, like your right arrow key. Do you have a right arrow key? Try the right arrow once more. All right, there we are. Okay, so this is the curve that you'll get, the empirical distribution function or cumulative distribution function curve that you'll get if a society is completely egalitarian, meaning all of the income, everybody has the same amount. So what you see here in the lower green line is up until we get to the mean income, wherever that is, and I think in this case, it's like around 70,000 and something for a household. Up until you get to the mean income, no fraction of the households have less than that. When you hit the mean income, because we all have the same amount, we bump up to 1, and that's the other part of this discontinuous curve, that green line at the top. Now, we've hit the mean income, all households. So any value above that, the answer to how many households have less than or equal to this, it's 1. So this is what the curve looks like when you have distributional equality. Everybody has the same amount. Hit the arrow one more time. All right. This is if no one had anything, right? So the curve goes straight up and right at 0 or right to the right of 0, and we immediately get to the complete fraction of the distribution. There's no income to apportion. Hit the curve, hit the arrow one more time. And this is what it looks like if only one person, so completely concentrated. Now I'm using the word for the first time, concentration. This notion of concentration measured on a distribution, right? Measured on a population. In this case, income is concentrated perfectly at one person. We move all the way up through the income axis on the x-axis, that's the purple line at the bottom, until we get to the last person, and that last person has everything, and then only then do we reach the fraction of the population that has income less than or equal to that value, and that's at that max value for the person who has it all. And so this is what inequality looks like when calculated via the cumulative distribution function. If we hit the arrow one more time. Oh, actually, go back one second. There's one more thing I want to say. So I want to say this because it's important for later. These data here, these are data that are binned. So from these incomes, you do not have the actual incomes of each of the underlying sort of taxpayers. What you do are you have a series of bins or categorized values, and then you have the frequency, and this is why this thing looks like a step function. You have the frequency or number of households that are falling within that value. So then you can calculate the share from number, and then you have the total number of households. And another thing I'll say that we'll come back to later is that this is truncated. These data are truncated. I can't remember if they're truncated. It might be 175,000 or something. Maybe it's 150,000. At any rate, past the truncation, so if you have 2 million or 3 million household income, it goes into this calculation and this statistic as if it were just in the last bin, which is 150,000. So that's something that's important for later, and we'll talk about that at the end of the talk. All right, please, one more slide. So from that graph, which is just basically how many people have how much, we can construct another version of the cumulative distribution function. It really is just a straight mapping from one way of seeing it to another via this curve called the Lorenz curve. And so basically the Lorenz curve is you take the total cumulative distribution and you divide that by total income. So instead of the curve being over income and share, it's over share of population and share of income or good or wealth or whatever you're measuring. And so Lorenz, another one of these characters, late 1800s, middle 1900s, statistician, mathematician, also socially interested. I think this was his paper in 1906. It came out in the American Statistical Association, and he was interested in comparing tax records from 2 different periods to see if the income or equality had grown or decreased. Now, this is his first graph of this curve that he defined. You'll see in later iterations of it, the thing is flipped around and the axes are put the other way. So instead of having a 45-degree line with a curve on top of it, you have a 45-degree line with a curve under it. We can go to the next slide. All right, more math. This is just an illustration that the distribution function, which says amount of good, share of population, is really the same thing as Lorenz curve, which is now share of population, share of good. And that's basically it. I wave my hands. These are exactly the same thing, just one is divided again. And go forward one more slide. All right, so this is the Lorenz curve on the same data that we just looked at, which is the money income for households in 2008. And I'm going to ask a couple questions that I can answer, in the course of the talk, meeting right now. But we can come back to you later and talk more about the meaning of it. And one of these I presage. So, if you go forward, hit the arrow one more time, please. Just one quick more time. All right. Okay. So this is the Lorenz curve for the same data. So we took that same sort of stepwise stuff here and we mapped it onto this curve by dividing again by the population. And so if you see that green line in the middle, the green line going the 45-degree line, that's the curve that you get if everybody has the same thing, right? And from the cumulative distribution, flat line up to the mean, bounces up to the total population and continues on in perpetuity. The 45-degree line in Lorenz curve, same thing as that other curve. These other curves here that you see that start off at 0, 0 and are bounded at 1, 1, which should go from share of the population to share of the good, give you a sense of how concentrated the thing you're talking about or measuring is, how concentrated the wealth or the income is. If we are at this dotted line, it goes from 0, 0 to 0, 1, and then from this would be 0, 1 up to 1, 1, that dotted line, that sort of backwards L. That's the curve, Lorenz curve, for a completely concentrated population where all of the resources are being held by one entity. And anything in between equality, the 45-degree line, and that backwards L is something that's not fully concentrated, not fully equal. Same data. And so we can see here in this data here, I've calculated an additional statistic here, which I'll just go ahead and say, which is the Gini coefficient. And the Gini coefficient is just a mapping of these curves. So from all of these curves that you could get, the infinite population of curves you can get between this line and this L, you can map each one to a number. That number you can scale, so it ranges between 0 and 1. 0 meaning the line of equality, the green line, 1 meaning that backwards L. It's a measurement of how concentrated the income, wealth, whatever you're measuring is of the population. So we see here these are the observed estimates of the Gini coefficient, right? The mapping of this Lorenz curve for US when stratified by, so-called race. So we see for the entire US 2008 bin data, just don't forget that, 37. So we're at 37%. Again, we can go from 0 and 1 concentration. For whites, 36, black, 42. Again, equal is 0. So what do you notice here? Well, the black population has wealth more concentrated. So more wealth is held in less hands than the white population. In between, they're averaged. Obviously, there are a lot less black people than white people, because in this sample, I'm just in general in this country, that's also true, because the average of 36 and 42 isn't the unweighted average isn't 37, right? The weighted average is, meaning that the number of people in that group are a lot higher. All right, so let's move on. Gini coefficient. So another character, same period of time, a contemporary of Lorenz, a contemporary of Russell, contemporary of Einstein, contemporary of Gumbel. There were contemporary of Hotelling, similar mindsets, also socially concerned. Gini's innovation was measure and rescale what I just said, the Lorenz curve, so that you can map it to one number. And there's not the best picture of Corrado Gini, but the only one I could find. Next slide, please. If we go to the next slide. Are we still there? Hello? Can we go to one more slide? Did we lose somebody? Oh, there we are. Yep, more math. This is just Gini curve, Lorenz curve, same thing. One's a curve, function over share of population, one's a number. Next slide. This is something we'll come back to later. So one of the nice things about the Gini coefficient is that it's a really illustrative. I mean, in general, I think people, and this is not my area, but this is just a supposition, that people understand scalars better than they do functions and vectors, right? A number, I can believe, a function, some curve, even though it may be more illustrative and give us more nuance, sort of harder to pick up. The Lorenz curve that's moving and animated at the top left is calculated from the same population that's giving us that scalar number, that Gini coefficient on the bottom right. So it's the same information, but look at how much more illustrative of the change in concentration the Gini coefficient looks like when compared to the change in the Lorenz curve. All right. So yeah, the animation here, playing around with PowerPoint. So shifts in the Lorenz curve may look slight when real changes in the Gini coefficient are significant, and that's what this is leading up to saying. So you can hit the arrow one more time. All right, and let's move to the next slide. All right, so observation. So now we've talked about sort of the precursors for measuring something across entire populations. There's this notion of fairness and equity. There's this notion of instantaneity and measuring things across the infinite. Now let's look at what goes on sort of in the applied world, in the zeitgeist, where we take income or wealth statistics and we stick them into these equations, and then we come up with numbers and we stand back and see what we have. All right, so let's move to the next one. So this is an illustration of the Lorenz curve, the calculated Gini coefficient, and then this bit here, which is the Lorenz curve at 1/2. And so it says Lorenz at 1/2 equals 0.031. What does that mean? So if the Lorenz curve is the mapping from share of the population to share of the underlying good, wealth or income, the Lorenz curve at 1/2 tells you how much half of the population has of this thing to be distributed. And so this worldwide, in this calculation, again, the data for this are about 10 years old, back when I was doing academic research on this sort of stuff. Half of the population has only 3/100ths of the entire wealth on the planet. So that's a 3%. You know, that's when calculated this way. What's the underlying calculation here? The underlying calculation here is an estimate of gross national product, but downscaled to 1/2 degree lat longs. And so this is a heat map going across it. Pink is less income. The darker red color is more income. You see most of the world is relatively poor. When it's calculated this way, it's down to 1/2 degree lat longs, with a few places, you know, of high income, and these are easy to pick out, right? The centers of commerce. All right, if we can go forward one slide. Same calculation, but done on administrative boundary. And you notice on administrative boundary, what happens is the concentration goes up, right? So when we're willing to calculate inequality across national boundaries, right, on these little sort of lat long boxes, it's shrunk a little bit. But when we agglomerate wealth into nations, it further increases. Now both of these are high concentrations, right? The other one was almost 0.8. This is 0.85. We're at the end of the scale of concentration. And now the fraction again here has even decreased. So half of the world, again using country administrative boundaries, 1% of the wealth. So not an egalitarian illustration of how wealth, income, gross national product is distributed across the world. Next slide, please. So that was the world. Now let's look and measure inequality at each country and see how it compares across countries. So if we'll go to the next slide. So this is an illustration of the concentration. So we're just taking concentration here on the y-axis, and on the x-axis, it's GDP. Now I took the log of GDP here because, and as you just saw, you know, the range in GDP and GMP is wide. And I take the log to sort of shrink that axis so that we can look at everything on one panel. But there's a leagues of difference between Japan, say, at the lower right here, and Barbados, right? So we take the log so they can sort of be put in a coherent way. And we're looking for a relationship between money and inequality, right? Slight, you know, and one that seems almost counterintuitive. Again, all of these things are just observational. There's no underlying model. In fact, almost everything I'm showing you here has no underlying model other than to measure this distributional quantity, right? There's no other statistical model going on than just the empirical measurements. But we see this curve, which is, you know, trying to capture a pattern between GDP and Gini, and if anything, the curve is flat and decreasing as money as GDP goes up. But you can see some things that are important. There's Brazil and that dot on the upper right quadrant. Lots of income, lots of inequality. Haiti on the upper left quadrant. Not much income, lots of inequality. And then there's United States. Not as much inequality as Brazil, but a fair amount, definitely above the average or mean inequality at that level of income, and high income as well. All right, let's move to the next slide. All right, and we just have to click through these little animations. So again, these are sort of, each dot is a country. These axes are the country's Gini coefficient score versus some other sort of metric. The Human Development Index is this first one. And again, we're looking for a relationship between the Human Development Index and this Gini coefficient. If anything, we see past the threshold, or really where all the data are grouped, that the HDI increases when inequality goes down. That seems to match with something we might have in our head about fairness and how people experience it. This next one, if you hit the arrow one more time, this is a measure of graft, and the share of economy that's unofficial, that not on ledgers. And again, as the share goes up, inequality tends to go up as well. There's some places that stand out: Nigeria, Brazil. The United States gets good scores on the officialization of the economy, but again, still high in relative inequality. And then this last one here, I have to move this thing out of the way, incarceration. So the incarceration rate for inequality, again, as when more people are incarcerated, places tend to be more unequal with respect to income. And there's the United States again, another, I hesitate to say outlier because that's a loaded term, but far out on the incarceration axis and relatively high in the inequality measurement. All right, if you go to the next slide, please. All right, so now let's look at some things that are within the United States. If we'll click the next slide. But this is a different measurement, and we can talk about this. This is not part of the Gini setup, although it's similar to the Gini measurement. It's another way of measuring inequality, but this I kept this one in because I just thought it was important. This alternate way of measuring inequality shows you the contribution across all the different groups, right? So before each of the inequality measurements we had up till now were for sort of closed populations, and we were measuring inequality either across administrative regions or within a country. Now we're going to measure it within a country, but and these are all, counties within a country, and it shows you the contribution, how much each region contributes to the overall measurement of inequality. We know what the overall measurement is by Gini. For this, we're somewhere, well, we looked at the 2008 number, we're about 0.37, 0.4, slightly higher now. And this again is our old data, but I just think this is interesting. So when you look at areas that contribute a lot to the total inequality, and we can talk about more of this measurement sort of voce. I just didn't want to go into the technical aspects here. Some places stand out: New York City, Chicago, Southern California. Right? These are places that are contributing a lot to the overall economic inequality. I could make some jokes about this, but maybe we'll make those in the Q&A. All right, please, next slide. Within the country, again, we see these sort of patterns. Again, no other statistical model here than just taking the official measurement at the state level. So we see inequality increasing here, crime. It's hard to sort of pick something out, but we do see DC. It's very interesting. They're an outlier. DC, and again, that's changed some over the last 10 years, but DC is relatively high in income inequality in administrative regions in the United States. But here at this point, they had the violent crime was relatively low, although they also score poorly in math and high in infant mortality. So these illustrations allow you to pick out places that are sort of pathological with respect to the overall sort of trends. All right, next slide, please. And there should be a play button on this somewhere. If this is still in PowerPoint, like if you click on the graph, there's a play button. Yeah, there you are. I like to let this go. So this isn't, I forget where I got this graph from, but this is from data from work by Thomas Piketty and Emmanuel Saez on looking at the distribution of income as it relates to tax rate for a very long time. So we looked at the inequality measurements, right? And we had the sort of steady state sort of thing here. I just want to point out, if you let it play one more time, I just think this is just a beautiful illustration. Look at the change in the top tax rate, and really the top tax rate at the 99th percent of the distribution over time. And this is something I think we can talk about in the Q&A section. Not a measurement of inequality, right? But perhaps one of the determinants of it. It's just a really beautiful illustration on what might be some of the drivers behind the distribution of measurements we can take. If you go to the next slide, please. All right. This is EPI, and this just came out, this illustration, I think just about a month or so ago. Again, not a measurement of inequality, but what you see here is the same distributional information. On the x-axis for the tax rate was the percentile of the distribution, right? So that would be the same axis on the Lorenz curve. The same thing here on the stratification of these different curves are different percentiles of the distribution, and we see the change in the wage rate along with that. So these are the things that we usually consume. The information stratified at some level, talking about the 99% or the 50%, stuff like that. Piketty is fond of not describing inequality in sort of either the Lorenz curve way or to use just a coefficient. And he said this, and I tend to agree. He finds it more compelling to sort of talk about which fraction of the population owns which fraction of wealth and things like that, to talk about it in terms of deciles. People seem to understand that, and the message gets through a lot better. If we can go on to the next slide. And then just a couple slides here. We're all at home and not together, so it seemed to be remiss to skip just a little sort of observational illustration of inequality and coronavirus. If you go to the next one. And so now we do let this run here for a second. We'll have to pass through a couple of times to get the message, so we just let it sit and I'll just blab for a second. So on the y-axis is an excess mortality score, just a way of standardizing what the excess mortality has been from last year up till now at each country. And on the x-axis is this inequality coefficient, right? And then the number on the upper right quadrant is a version of the correlation across these entire collection of countries between the this inequality measurement and this excess mortality. And you'll notice what we're going through here, each of our strata by age. So we start off with 15 through 64, then we go from 65 to 74, and then we go to 75 to 84, and then we go to 85 plus. Back to 1564. The strongest relationship and change between excess mortality and inequality, the strongest relationship between excess mortality and inequality is when we take the youngest age range, demographic age range, right? When we look at excess mortality and it's the older strata, there's less of a relationship to it. But when we look at the younger ages, wow, there's a much stronger relationship. So we're looking at a difference between 0.42 and then 0.5 and then even a negative one. And these are probably just spurious maybe. But this is the effect of so underlying it, again, no statistical model. There are latent things, other ways of describing each of these things in a proper way, in a modeling way to see what the effect of this is on that. But I think it's powerful that when you look at the younger strata and you look for a relationship between inequality and excess mortality, you find a stronger association. So, that's something to chew on. All right, if we can go forward one more slide. And then lastly, some of this we can talk about again in the Q&A sort of more loosely. I did want to include a little bit sort of in the business world. What's the business world? We're all, working at different things. And one of the nice things I'll say about taking this job at a music company is at the end of each day, I stand back and I say, I'm just trying to get people to listen to music. It's not a desultory thing, and it's consonant, I think, with a lot of the work that I've done and observations I've made on sort of distributional inequality and fairness and stuff like that. If you can go forward one slide, please. So now we're back to, if you'll remember this slide, it was juxtaposed with a Lorenz curve, and the point that I was making the first time we saw it was that the Lorenz curve could shift a lot. What would shift, you wouldn't be able to see the real difference in what happened by just sort of eyeballing the shift. But when you look at it in terms of the mapping onto the Gini coefficient, you can see it very, very well. And here's where we see this. So this is it's rescaled, and it's not the whole population. This is all proprietary stuff. So this is a version of this data. But what you see here is concentration in a streaming market over time. This little bit in here in 2019, I'm not sure about the validity of the data, but what you see is concentration decreasing until about that point, and then sort of taking off again. What could this mean? What does it mean for music to be concentrated? Well, this means that more of the listening is happening in on fewer ears, right? Is that a good thing or is that a bad thing? Let's go to the next slide. Turns out that in these data, in these observations, when we look at the volume versus the concentration, they happen in inverse relationships. So stepping again, there's no underlying model here, no other sort of latent sort of variables to explain anything, but this is sort of a bald sort of statement, just looking at the directions of the two curves. When concentration decreases, listening overall goes up, but when concentration increases, listening seems to go down. So from the music industry perspective, one of the things you'd want is there to be less concentration in the music market, right? You want more ears listening to more stuff, more uniformity in listening, not just a few ears listening to some stuff, because volume and people listening to music is how the music companies make their money. But just something to notice. All right, then we can go to the next slide. So let's have the Q&A, and I just wanted to put up the themes from the beginning here. We want to, axioms, dependence, scarcity, measurement versus obfuscation. That was that bit about how the CPI data are measured and binned and truncated, and our ability to be able to assess inequality properly. And then to the right there is my sleeping child. I always like to put her at the end or beginning of each slide. It leavens things. All right, thank you. And love to hear your questions.
Hi, thank you very much. That was incredibly eye-opening. So we do have a few questions, and I think we have about 10 minutes. So one question that came in from, I think that you sort of have answered this, but not quite. A question from John Tabori, who's on the call. Has your view of inequality changed as a consequence of the impact of the COVID-19 pandemic, particularly in light of the fault lines that the pandemic has exposed with respect to access to healthcare, housing, and job security?
Right. No, that's fair. And I can, so let me say that these are all outside of my ken. There's people who research, live, work, contribute in this area that are more qualified to think about these things and opine on them than I am. Having said that, if we go back to Rawls's first sort of maxim that maybe we can't maximize uniformity, i.e. we can't drive concentration down to zero, but we have to apportion resources well, right? And that a society that maximizes welfare function is one that apportions resources properly. And this is just a comment any of us could make. I don't think any of us have been pleased by what appears to be a pathological operations behind sending out vaccines. It's certainly a comment on the healthcare system. Again, not my area, but one of the things that I like to say, and when talking about inequality, these distributional measurements, is we're really all in it together, right? I spent the first part of my career doing environmental statistics, which was all about how to sort of reframe and refactor consumption. One of the things that I think is lost in the discussion about inequality is, are we all just looking to consume more at an equal level, or are we looking to consume less and apportion things sort of more wisely? And I think, this past year has illustrated to everyone that we have problems with the way in which we assign resources, and we have problems with being able to act in a collective way. We're measured in a collective way, right? The spread of a disease, it happens over a population in the same way that we measure inequality over a distribution. Whether you like it or not, your fate is tied up with people in the same administrator group as you, in the same area as you. Whether you like it or not, these inequality measurements have to do with how we push around wealth and income. And so I think that, the important lessons and things to think about when we think about how we've realized all this stuff. I think one of the, and I'll just say this last part and just sort of riffing again, there's people who do health and stuff better than I do. But I spent the first part of my career as an environmental statistician. I had been doing it since the 90s when I was an undergrad. And I remember after the first Rio conference in '92, there was this excitation about how we were going to become more aware of the environment and really sort of forestall climate change. And then we had this orgy of consumption in the 90s, these large SUVs and all of that. One of the things I hope we get from this, 10, 20, almost 30 years later is an understanding of sort of the limits of consumption and this collective notion that we're all being measured together in closed populations, whether we like it or not.
Thank you. Do you have any views on how people of color might be able to use these kinds of statistics to their advantage? in the workplace or otherwise.
Sure. So again, I'll give the caveat that not my area. There's people who do this a lot better than me. I can recommend you look at some of the papers by William Darity or Derek Hamilton, who do great work on inequality and wealth, and then the way that it's measured and sort of affects and burdens people of color, Black people. But just commenting on how can we use information to sort of navigate, jobs and things like that. So I'll tell you, and so let me say this first thing, whatever. This has less to do with people of color than more than sort of how to understand sort of distribution of statistics and how they affect. So I work for a media company, and before this, I also worked for a media company. One of the things you're very interested in at a media company is the audiences that consume your content. And when you get better at it, you learn it's not just the audience, that there's this notion of concentration in the way that an audience consumes your content. You want to be able to describe, target, and reach a very sort of tightly grouped audience of people with a very sort of pointed and nuanced message. And so that understanding then about how populations are stratified and how to measure concentration is important in that field, because it's one of the metrics that sort of predicts success. I hope that's useful.
I'll ask you one more, which I think is closer to what you do if I'm following correctly. So how can non-classic measures and data be used to change classic ways of gathering data and measuring impact that are increasingly seen as inappropriate for questions raised in recent protest actions related to inequality and poverty?
That's interesting. Let's see if we can pull that apart yet. By way of introduction, one of the things that people are noticing about modeling populations and their behaviors are some of the nuances or biases that may come up in measurement because of the presence of sort of latent variables of information that you don't account for, right? So people are worried about the machine learning algorithms, for instance, facial recognition. Facial recognition algorithms have a higher false positive rate for people of color. That could happen for a bunch of different reasons. The faces might be different, the shading might be different. There are less people of color in databases, so the discovery rates are affected. I'm of the mind that you do include as much information as you can in modeling, right? Like, I don't think it's a racist thing to include in a model for facial recognition other covariates that may help you predict the face, or in a credit model. The problem is that people think they think including information means imposing bias. But as a statistician, I feel like it's often the opposite. The ignorance or missingness of information actually increases bias, right? And it makes it harder for us to explain things. I think there's a different thing between the legitimacy of doing something, meaning legitimacy with respect to sort of fairness and all that, and the sort of utility of doing something. And I think that a lot of people, and rightly so, have questions and concerns about governments, corporations, et cetera, doing things which have heretofore been illegitimate, but may have a real utility, right? And so then this, I'm finding my way back around to sort of answering the question about people of color. I mean, what can people of color do? Learn as much as possible. Be specific. I started off doing statistics. I'll tell you, this is a colloquial sort of story. My dad was a psychologist, and I remember when he was finishing his dissertation, he had to get someone to do his statistics. This is back in the 70s. And I remember him walking, going to someone's house, the statistician, and paying him like $270 or something like that. And I remember, like, what are statistics? Learning and being the master of information is crucial for people of color, for anybody everybody, and I think especially for people of color who suffer historical disadvantage, being more diligent about being on top of information and how to assess it is more important. Yeah.
Thank you. So I just want to say thank you very much. That was incredibly eye-opening, and I love the concept of being a master of data and a master of facts as a way to change what you see around you. Thank you very much for this presentation, Dr. Abayomi, and I think I speak for everyone else when I say we're very grateful to have had you here this evening.
Thank you.
And thank you to all the alumni here that have joined us this evening. Thank you for taking time out of your day to spend an hour with us. I hope you will join us again. And if you have any suggestions or any ideas of other things that you would like to hear us see a spotlight, please get in touch, and have a good evening, and be well and stay well.
Right.
Good night.
Thank you, everyone. Good night.
Thank you.